Hello again, and tonight we're going to talk about artificial general intelligence using the Chat GPT as an example. And yes, the title is a bit of clickbaity, but it's my conclusion as to the current state of artificial general intelligence and generation engines like Chat GPT. Needs a parent, not more teachers or students. So there's an organization called OpenAI that Elon Musk put some money in initially, but then separated and had them go on their own way. And Tesla and Tesla Bot and all those things were parallel developments. But it looks like Microsoft has invested heavily in OpenAI, and they want to put a Chat GPT kind of engine into the Microsoft Edge browser. So instead of using the current search engines, it will synthetically generate responses. I still think it's going to be advertisement biased to what you see first, but it's what they do with their billions. I've had a few people in my audience request a presentation on artificial general intelligence, AGI, or just artificial intelligence in general. And that's either because I'm perceived at being good at picking loose threads. So if there's anything that's a weak link in this stuff, I'll probably find it. Or because AGI is based upon software and computers, and I have career and training experience, and that's my wheelhouse is software systems, especially large scale ones. I became a bit more interested in ChatGPT when it started generating software programs and scripts in several different programming languages for different computers, including obsolete computers like a Commodore 64. And it did a pretty bang up job of even getting the software to fit within the performance and memory constraints of such an old 8-bit computer. So I thought, oh, that's pretty good. They must have absorbed some designs of things that allow it to stay within those boundaries. So I thought maybe it's overdue for me to take a closer look at this stuff. And when I was looking at sort of the statements of supposed fact that ChatGPT was making, I saw that it had proclaimed that the James Webb Space Telescope had been the first to discover something that it wasn't. And I thought, well, so it's got some foibles. But before people get carried away with it being all-seeing and all-knowing, I better dig into this thing and see what the current state of the art is, where it's going to go next, how much farther it has to go, and whether or not there are gaping holes. And from what some people are saying about how they're becoming sociopathic, have they gone off the rails with these things, and put together a presentation on it. So kind of started last week, but more intensely this week. I did my research, darted down several rabbit holes, and came up with this presentation. There are competing organizations that are doing artificial general intelligence in different areas: text, software development, vehicle driving assistance, supposedly creative works like art, music, literature, and journalism. And we're going to be looking at AI in general, but as the example, we're going to be looking at AGI as personified by ChatGPT. So as Helen suggested, why don't you start by just basically getting into ChatGPT and asking it to explain artificial intelligence and artificial general intelligence and where things are and kind of like what the holes are. So I actually got an account with ChatGPT. It's easy, doesn't cost anything. But I posed the questions at the wee hours of the morning when it wasn't too burdened. And I literally said, explain the current state of artificial general intelligence. It took about 6 seconds before it started spewing out words. And then for about the next 30 seconds, very slowly, almost at one word every half a second, it started spewing out this text. I thought it was a good discussion of the topic. It was sounding a bit too canned, as if maybe somebody had biased its response with a little bit of the OpenAI marketing. So I said, well, that's not bad, but let's give it something tougher that I doubt that anyone would have prepared it for, and see how well it does when there's even questionable content to base it on. So I said, explain radiation reflection pressure, how it can be used for deep space propulsion, and why it would be better than chemical rockets. And again, it only took about 6 seconds before it started spewing text. And it spewed text for about 30 seconds. And then it stopped and it said, do you want me to regenerate that? And I thought, does regenerate mean you're going to think it over again and come away with a different answer? So I said, no, I don't want to do that. But it did have a little button where it said, would you like to comment on ChatGPT's response? And I basically said, it's okay. It's a good synopsis of things, but I couldn't leave it at that. I thought it was a bit too focused on solar sails. So I asked it another question. Can radiation reflection pressure be implemented without a sail? Which is something I'm fond of speaking about. And it started spewing, about 6 seconds later. But then as it was spewing out the text, there were noticeable pauses of like between 1 and 3 seconds as it was getting other concepts. It was like scraping the bottom of the barrel, so to speak, on a topic that it wasn't so prepared to just readily respond. And it came up with this. But the first thing that I noticed was my question used the triple radiation reflection pressure. It dropped the word reflection and just said radiation pressure, because that better fit its response. And we'll get into reaching back later in this presentation, but it's because it's advanced enough to do what is known as reach back. So it knew what I asked, it started answering, and then it realized, oh, I can't provide information on exactly what you asked for. So what do I drop out to make it fit the information that I do have? And so that's how it came up with this. And since I had the ability to click on a button that says, would you like to comment on what ChatGPT said? I said, sure thing. So up popped the text box, and I commented about NASA EagleWorks and their efforts in non-ion based, non-solar sail based radiation reflection pressure for deep space propulsion. So let's see what they say in response to that. So many years ago, I used a piece of software called ELIZA, and we'll get a little bit into that momentarily. But ELIZA was a piece of software that it would ask how you're feeling, and then you would respond in text with how you're feeling, and then it would take what you said, turn it around on you, and why are you feeling that way? And you could go on with a fairly lengthy conversation with ELIZA, but it never went beyond the information it had immediately at its disposal, and it never tried to tie in other things that weren't related to the original question. So I see ChatGPT as kind of a technological incremental advancement on ELIZA, because now it has far more data to work with, and it has access to the internet, but it doesn't do live research on the internet, and it doesn't create new postulations. So that's kind of where I see it. But what is it? So in 1950, there was a gentleman by the name of Alan Turing. He was one of the guys that worked at Bletchley Park over in the UK and found out how to crack the Enigma machine that the Russians were using, Germans were using in World War II to basically encrypt communication such that their adversaries couldn't decode it. And they created a programmable computer. It's not that easily programmable, no compilers and such, just a lot of mechanical stuff. and vacuum tubes as valves, as they call them, but essentially as diodes and switches. So he realized that if this stuff really gets advanced and fully programmable, you could create software that would imitate human behavior. He didn't describe it as artificial intelligence. He described that software as being the imitation game. And the name of the movie is called The Imitation Game. But so was born what they call the Turing Test. If I'm a person and I sit in a room, and on the other side of a barrier that I cannot see, there is dialogue coming from that side. Today it would be computer generated, but back then it was a person either speaking impromptuously or speaking on behalf of a computer, because the computers couldn't speak back then. So if I had this observing person give a question and then have either a person or the computer give a response, can you tell the difference? And if you could not tell the difference, when it was later revealed that was a computer, then the computer passed the Turing test. If you readily realize,
I don't have an answer for that.
In the kitchen, she says, I don't have an answer for that. If you couldn't readily recognize it was a computer, then the computer would have passed the Turing test. If you remember the episode of Star Trek The Next Generation, when they were talking about sentient life forms and how data is sentient, they came up with some rationality as to how you would know something sentient or not. And all I can say is animal rights activists and philosophers have had a field day with that concept of sentience for decades. Sentience just means in response to an observation or an input, it can behave in a manner such that it appears as intelligent as human beings. So it must be sentient. And then you can come away with all kinds of rules. The rules are usually slanted to make it impossible for something you don't want to be sentient to actually be labeled as sentient. And another thing from Star Trek The Next Generation, something called the ineffable quality of human beings. So it's generally believed that human beings have an ineffable quality that you'll never be able to document, reproduce, or surpass using computer software algorithms. So human beings will always have an edge over computers. Well, we create them, so we must have an edge. Right, okay. But it just means that that quality has not yet been analyzed, described, or replicated, and therefore it will remain a mystery. Humans will always have an ineffable quality. And many people say, because humans can be artistically creative, that gives them an ineffable edge over any software you could ever write. But being a software engineer of various topics, I see it simply as a means of keeping the carrot out in front of the donkey. If I can always say, human beings will have this aspect to them that you'll never be able to document, program, or reproduce with computers, then the carrot will always be out in front of the computer donkey. But because ChatGPT can now generate works of art, literature, journalism, and develop software programming, that whole human ineffable quality seems to have been demonstrated as, well, it's doing it, so must not be that ineffable. But just to quote, not quote, but make reference to Star Trek The Next Generation. When Data was confronted by the Daystrom Institute's representative who said, I'd like to take you apart, study you, and then put you back together, Data said, what if there's an ineffable quality of me as this singular, unique android that once you disassembled me, studied me, and reassembled me, I lost that ineffable quality? So, you lose the secret sauce because you took it apart and you put it back together again. Or as people with electronics say, you let the smoke out. Well, that doesn't line up with the actual storyline, which is data was originally discovered as disassembled and was reassembled by the Daystrom Institute. Nothing was lost then, and his brother Lore was actually disassembled by the Federation because he was deemed harmful, and later on he was reassembled, and he didn't seem to suffer from any ill effects from that. Granted, he had other sociopathy based upon his programming, or incorrect or incomplete programming, but that whole ineffable quality thing just kind of goes out the door once you actually spend some time analyzing it. But I have a real world example, something called MIDI, or Musical Instrument Digital Interface. When they first came out with this, it was a means whereby a computer could make a synthesizer play music. And musicians were very concerned that their jobs were going to be taken away from them, because computers would be able to make sounds just as good as paid musicians. And so they called upon this ineffable quality to say, human instrument playing musicians will always be able to have subtleties of performance that will not be possible with software. However, conductors and musical producers said, MIDI sounds like a great way of not having to pay these. And so they enhanced MIDI such that it had a full command set of a musical conductor. If you, as an instrument playing musician, were to play in a manner not directed by your sheet music or by the conductor, you wouldn't belong for that orchestra. You play what you're told to play, how you're told to play it. And if all the ways in which a human being can be told to play any kind of instrument, whether it be a keyboard, horn, reed, woodwind instrument, string instrument, or percussion, all the subtleties that the conductor has at their disposal, if you can put that into the MIDI program so that you can then command a synthesizer to play with all those subtleties, you now have taken the human ineffable quality out of musical instrument playing. We now have two steps of musical generation. The first is the composer will write the musical score, and it'll get converted to MIDI programming. The MIDI programming will then drive a high capability synthesizer bank to play all the instruments needed. So you can then show to the producers of your movie actually what the musical theme is going to sound like, or you can create music that actually fills the background while you're reviewing the video, the dailies. So you can very quickly turn to the music, and it's only when you actually go to produce the final work that you'll pay for an orchestra to play the instruments. So we still do that, but we hold that off until the last step so we don't have to keep paying them. But now they've taken it to performance art. And Helen and I actually attended this. There is a Star Trek performance art musical event where you pay money and you go see an orchestra performing all the various theme musics from all the various Star Trek series and movies. And it sounds really great because you as a human being have paid for other human beings to play music for you. So it elevates you. It feels like you're commanding them. You've paid for them to do this for you. It's a service. That's really great. So that's actually broken out as performance art. So MIDI has taken the jobs of many an instrument playing musician, but when production time comes, the producers still want human beings to perform, but the human beings are still performing with it on the same guidelines as MIDI supports. But ChatGPT has taken one more person out of that loop, the author of the music to begin with. ChatGPT can now create what are perceived of as original works of musical art, and then have MIDI play it. or you can have the MIDI score produced, or it can send you an email with the score attached in musical notation. So yeah, as money is on the line, we always find a way to have computers, do what the people that cost money do. But that was my first example of the prognostication that musicians will always have an ineffable quality, and then MIDI got improved to the point where that quality didn't actually pan out, and software can now do all the nuances. So if that's the case, what is actually AI? AI is a charlatan. It's a programmed electronic system that allows human beings that are evaluating it to perceive that it's behaving as a human would. So software algorithm plus training that mimics preferably correct, but at least acceptable to other humans. That's all AI needs to be. It needs to be no more sophisticated than that. That's AI, not artificial general intelligence, just basically artificial intelligence. It's considered artificial because the active request to response was not processed, nor was it produced by a human being. That's the artificial part of it. But what is intelligence? That's the part that took them some time to figure out. Now that we know there's no ineffable quality, simply put, humans are programmed by numerous factors and they behave in a manner acceptable to other humans. So human beings get formalized education on historical information, current facts, potential future outcomes, whether it's self-taught or not, training. The process by which you take inputs plus the training and produce results, generation. Correcting the prior results based upon the updated information is called heuristics, and that folds back to training. Train yourself. As you learn, as you correct, you go put that back in the training, and you have a closed loop that will improve itself. So the next thing is morality. Somehow teaching the software right from wrong, not doing any harm like theft or murder, being truthful. But remember, human beings are subject to dogma. That's your religious teachings that tell you, behave this way or you're going to hell. Or somebody won't like it and you'll go to hell. It's kind of hard to embed dogma into a computer. It does how it's told to behave. And if you're giving it open-ended, training and then doing its own generation and heuristics folding back on itself, there's no avenue for something like dogma. So in humans, the laws and enforcement of the laws are the last line of defense against sociopathy. Morality. So if a computer doesn't have dogma, but its instructions are its laws, and it knows they're inviolate, they're never going to violate them because that's its programming, that's the only way you're going to get morality into a computer. The only thing that's left, and I think that computers will eventually do it, is autonomously connecting dots or taking leaps. Maybe the only quality left by by humans that will have to have computer algorithms. But think about all the times that human beings make an incorrect leap of faith. They think something that's the way it's happening, or that's why it's because that, and they're wrong. And only once they realize that they're wrong do they actually correct. And so computers today, executing as artificial general intelligence, can come away with wrong information. And there needs to be some way of getting that wrong information back into the computer as, that's not right, should be this, correcting it. But even when it's not AI, even if it's just recording information, there is a website called Wikipedia that people put information in and other people come along and correct it. And it's the closed loop continual correction that eventually gets you a very long diatribe about a subject where predominantly it's correct, but you have the opportunity to correct it. So humans assign intelligence to software executing systems based upon its ability to understand requests and produce a response that mimics what would be a human response. So the software just basically has to pass the Turing test and be no more sophisticated than that. So AI, charlatan, acceptable to human beings, that's really all you need for AI. And the three functions that it's doing, if you scrape below the surface and you find out that it's really only doing a couple of things. It's taking in information like this picture of a bicyclist who's riding along a road near a forest, and he's got a helmet on. So the computer needs to have all that information tagged. So it has to decompose the items, in this case, based upon shapes and colors. What are those things? Well, it doesn't know what those things are until it has even more of these things to decompose and tag. And that's how it learns. You give it more and more information, and it generates item decomposition and then tags them. And as it sees more of the tagging relating to similar, if not identical things, you could teach it things like, okay, if I only showed you this picture and told you that was a man on a bicycle, you could tag, I know what a man is, I know what a bicycle is. Okay, man, cyclist, helmet, he's on a road, there's a forest in the background. Got it. If then I showed you a picture of a woman in the same picture, I would have to go in there and manually tag it as, now this time it's not a man, it's a woman, but the rest of it's all the same. So today, even ChatGPT has human beings that are helping with the decomposition and tagging. But as the amount of data going through the system increases, it will get better and better at doing its own decomposition based upon other things that it's had in its input and tagging them the same way. So it's kind of a closed loop rolling forward. Now, when it tags these things, it creates associations of like, I saw a man, he was a cyclist. Are all men cyclists? Do all bicycles have men on them? It has to create these weights. Like, what is the probability of man on bicycle versus woman on bicycle versus man on horse or woman on horse? You know, you have to put in probabilities that are essentially weights. How often do you see a man on a bicycle versus a man on a horse? So all of these weights become values associated with the tags. And then it continually updates that based upon information it gathers as it actually executes on based upon the data. So you have training. Now you have execution, or in neural network parlance, it's called a decoder. The system takes slightly less massive input, like a car driving down the road versus a million cars driving down the road. It's still considerable volume of data, and it has to dynamically match what it sees with the tags that it knows about, and then based upon the weights, it will come to a conclusion that its outcome is, I should steer around that, or I should brake, those kind of things, or slow down even. So in execution, it does a lot of the same stuff as training. It decomposes the item, it categorizes them, it evaluates and weights them based upon its training, and it can feed back in and update the tags and weights. And it provides a conclusion action, as in, am I going to adjust the car's driving behavior? Or, you know, in the case of ChatGPT, am I going to make a statement? Am I going to put some text out and say something? In the case of artistic endeavors, am I going to make the music play a certain way because you asked for me to play it like Bach? What does Bach mean? Well, I've got an entire database of tags associated with Bach. So that's how it shapes what it produces, is based upon the execution of the tagging and the weights that it already has defined. For early AI efforts, computers attempted to play directly with string values, the words that it was being given. So the neural network actually had in the nodes the words. So you would see like this network mesh of words, and you would say, what is the probability of this word followed by that word followed by that word? And then they realized words are strings and they're variable length, and they take up memory, and they really get in the way, because once you judge it, all you're really doing is taking a weight and matching it against another weight. and coming away with the next weighted step in the network you want to do. So it's all just numbers. And they, the light bulb went off and they said, why don't we separate the words from the numbers? So the position in the neural network is a number. The weight is a number. Once I need to make an output like words on the page, then I can go back and say, oh, that number, I can look up and get this word. And I can save data space, because if under two different circumstances, a conjunction like and comes along and I need to reuse that, I might see a lot of places where and comes into play. So I'll use the same value, but it'll appear in a different place in the network. So I can string them together, but when I go to make the output, the tag identifier for and is always the same. I'm reusing it. So it really reduces the amount of storage space. And because it's just numbers, the computer can process it faster. And if instead of making it 64-bit numbers, you made it 32 or even 16-bit numbers, because 16 bits, is 32,000 nodes in your neural network. That's a lot of neural network. So you can make the numbers smaller, which makes the computers cheaper to make, faster, and you take all the strings, the text, and you put that on the inside and the outside, which makes it run even faster. So AI processors, neural networks, work with numbers. They're not out there comparing words to see if this word, that word. They do that during the training when they're tagging. So all the neural network is doing is, I'm here, what is my best next step, and am I done yet? So that's all the neural network is doing. But you can apply this to anything if you take all of the identifiers and put them on the outside and you just run numbers in the network. But how do you decide when you're at a particular node in the network what getting to the next node means for the overall picture? And there are actually algorithms for this, and you can read public, very head-banging research papers on it as to how you know where you want to go based upon where you are in the network. And it's just comparing numbers. There's something called backward propagation that's losing favor at the moment. And there's another thing called forward propagation that is faster, but and requires less storage, but it doesn't always get it right, because it doesn't go backward. It doesn't reflect upon what it's already talking about. So it can go off on a tangent, just like people do. So AI, not AGI, not artificial general intelligence, but just simple artificial intelligence, is already in your daily life, and it's been there for some time without you realizing it. So as you're typing in a text message on your phone, and it's telling you what word would come next, that's a linear predictive search algorithm based upon AI, because it's got a large database of text messages, and it's seen lots of strings of words, and it knows if I see this word followed by that word followed by that word, hey, the next word has got to be dog. So it actually spits out the word dog, and you can hit tab or next, and it will automatically insert the word dog, which is one of the ways where you see somebody texting, and they don't type all that much, but an entire verbose text message comes out at you. And it's because the AI of predictive texting is actually putting in all the rest of the letters. So they're just hitting, introductory information and then tab, 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 done. And they might throw in a personal pronoun of a person's name or something. So AI is already there with predictive text. How about travel generation, travel directions? It's great that you can say, I want to go to this location, take me there. And it will know where you currently are. It will analyze from all the other inputs it's ever received where you're telling it you want to go. And it will come up with a conclusion as to, I think you meant here. And it'll give you a couple of choices. And you just, quickly, blindly click, and you select the correct destination. The actual route map generation, that stuff's been around for some time. We used to do it in printed circuit boards to lay out the boards because they were three-dimensional. So the algorithms for doing the routing, they had to be modified for traffic, but the routing algorithms themselves, the math for them, that's topology. That's been around for a long time. So the AI bits of travel generation is more about you typed in what, where do you want to go? That's more of the AI. How about vocal command for home, business, and vehicle automation? The likes of Alexa, Siri, and whatever they call Google. So when I was working with computers in the 1980s, we had this thing called a Commodore Amiga. And the Amiga could do speaker-dependent discrete utterance voice recognition. So I actually taught it a few commands where I could get it to control via infrared my TV, my stereo, things like that. This is 1985. And it worked fine. But I could not spew out an entire sentence with all the words like connected together. I had to have discrete utterances like computer, stereo, channel, name, WRMF. And it had a table of channel names to frequencies, would look it up, and then tune the tuner to that. And that way I would have it tune the radio by voice. But it only knew my voice, and I had to have a little bit of pause between all the words, and it would do it. It literally could do it. So was that AI? No, it's just software. But nowadays, it can be speaker independent. Somebody new to your house can walk up, and if they know to say the opening word, they can command your lights if they know what your house has. So your house has an account associated with whatever service you're using, let's say Amazon Alexa. So your account has all of the devices that you bought and hooked into your network, and you've given them names, or it's given them names. So you can command them by names. But the AI bit is you can compress all the words together, and it can pick the words apart. And if you're close to it, it will do the right thing. So I have a TV in my family room. I have a TV in my bedroom. I predominantly watch the TV in my bedroom, not the family room. So when I say TV, it knows I probably mean the one in the bedroom. So I don't have to say bedroom TV anymore. It heuristically folded that on itself based upon the number of occurrences and said, okay. So you think it's getting more intelligent. It's only getting more intelligent at a very small scale. But we think of it as very much more progressed. So what about artificial general intelligence? This is the big ticket item. This is the first company that can do this with self-training is the one that's going to have command of billions or trillions of dollars of revenue over the next 30 years. So you have training, and then you have execution. But if you can train bigger databases faster, more tags, and then you can apply that as a general algorithm as opposed to being dedicated for just driver assistance for cars. If you can just have it say, here's the data that I've been fed, establish the categories and the tags and the weights, and just grind it out. And now I'm going to give you something totally independent of that, like, I don't know, a robot moving around the inside of a building it's never seen before. It's the same thing. It's just data about its surroundings and coming to a conclusion as to what to do next. So AGI, or Tesla's full self-driving, or the Tesla bot, does not have to have a predefined road. It doesn't have to be what they call GPS pre-mapped or geofence. You can put it on a road it's never been on before. It knows road driving instructions and how to behave, so it can do that. But the less capable solutions like Waymo Driver or Mercedes-Benz driver assistance claim to be more advanced than FSD, but the problem is they have to have prior mapping, geofencing, LiDAR, radar, ultrasonics, because they have to be put within a boundary, and you cannot take it outside the boundary. I was watching a Waymo demonstration video by somebody totally unrelated to Waymo, and I took away a couple of things. It does the same panic stops that Tesla Full Self-Drive does to avoid hitting things that it thinks might be a problem. So yeah, two completely different AI systems trying to do autonomous driving come away with the same human perceived problem of panic braking. And it doesn't have to come to a stop. It can just be like a little quick tap on the brakes, and the passenger feels uncomfortable. So they both do it. They have to learn around that. But the other thing I found out was Waymo and Mercedes-Benz driver assistants do not drive at full speed. So Mercedes-Benz says, we'll drive on the highway at not faster than 45 miles per hour. That's not highway speed, so it won't actually go on highways. And the Waymo goes out of its way to drive on city streets at 35 miles an hour versus taking an expressway so that your travel time is less. Once you have that full self-driving, how about full self-walking? You take the same concepts, you put it in the Tesla bot, and now it knows how to walk around an office space without bumping into walls or desks or chairs or people or trash cans. But you never had to train it for that. It just knows obstacles, and obstacles are something you should avoid. And when you're carrying something, you can either put it down on the ground, which is more effort, or you can, based upon its weight, put it down on the desk surface, which makes it easier for people to get to. So it's those nuances that are really going to separate kind of the men from the boys in the realm of AGI. So I was also looking at the computer hardware it takes to do this. And years ago, computers didn't have what is known as floating point math or trigonometry built into the general purpose processor. It was either emulated in software or it was executed with an expensive thing called a coprocessor. And early attempts at making AGI into something that could be rapidly executed by computers led to them being coprocessors. They made special purpose computers that would run quickly external to the computer. And ChatGPT is actually a special purpose computer designed for artificial general intelligence, the generation phase of it mostly, because the tagging is still a lot of human stuff. So what you see there in the picture is, it's not called a computer chip. It's called a silicon surface that contains multiple computer chips and electronic components. And those are at the core of OpenAI's ChatGPT. The very regular array that's in the center, those are the execution units. The squares at the top and bottom, that's the memory arrays. So classical computers have been around for a long time, and this picture dates back to the 1970s. This is an AMD 2901 bit slice computer. This is one of the 16-bit versions. I actually wrote software for one of these things once. And it takes very, very simple instructions, and you can join them together to make more sophisticated instructions. And that's what they're doing. If you wanted a regular general purpose computer to do AI, you would have a way overpowered, way over capable computer that isn't going to do it very quickly. So how do you make it faster? Well, you make it a coprocessor, or you give it its own memory or buses or all those kinds of things. Nowadays, computers, the general purpose processors, will actually have heterogeneous execution units in them. They'll have like an ARM processor that is running at 2 gigahertz. You'll have 2 of those cores, and then you'll have 4 cores that are running at like 1.5 gigahertz, because you can make them smaller and cheaper that way. And if you're executing script things that are in Python or JavaScript or Java, those can run on any of them because they're interpreted, and they'll just run faster or slower based upon which core it's running in. So you don't notice that your phone that has 8 cores has only 2 high-speed cores and a number of medium speed cores and then 4 low speed cores. And the stuff that's running in the background just runs a little slower. But how about truly dedicated chips for various things? Years ago, they realized that analog hardware in mobile phones was getting to take up too much space, was producing too much heat, and cost too much money to keep making it over and over again. As frequencies changed and as modulation techniques changed, we went from no G to 2G to 3G to 4G to 5G, and they kept having to reinvent the wheel. So long about 3G, they said, why don't we make a computer and we will convert the analog signals to digital data, and then we'll have very sophisticated, simple algorithms that will do processing. And if it's supposed to produce radio frequency out, it will do a digital to analog conversion. So all we have left is the actual transceiver. So this allowed phones to go from something that was the size of a brick to something that was a flip phone that fit in your palm. It is because he used DSP. They did the same thing with computer games. Computer games and animation started doing some really amazing things, but they were starting to slow the computer down because they were using general purpose processors to do it. And they decomposed what they were doing and found out that a lot of what they do is rendering shading and textures in the image. The actual drawing of the major parts of the image, that's pretty straightforward. So you need a few cores for the graphics production, but mostly what you need is hundreds to thousands of shaders and surface engines. And those are very simple. So you could have a graphical processing unit that you would put on your video card that could do all this stuff. Now, your mobile phone likely has at least one, if not three, DSPs in it, because you've got phone, Wi-Fi, RFC, RFID tags, GPS, all that stuff. They're all radio in your phone. I still think there's at least 2 or 3 of those that are separate DSPs. Your mobile phone, your tablet, your laptop, your desktop computer, all of them have some kind of capable GPU. But mostly what they're doing is they're flipping frame differences between video frames. We affectionately refer to that as video. So instead of making a full image of every video frame at 120 frames per second, all it's doing is conveying the differences between the last frame and the next frame. And occasionally they'll have a full refresh frame. But when it's converting the differences into something visible and it's decompressing the compressed data, sometimes it'll get it wrong. And the best way you can see that is if you're watching a movie that has explosions in it and it's very highly compressed, like showing 720 on your mobile phone, you'll see that the explosion goes from this nicely detailed cloud to this big pixel splotchy thing. And it's because the graphics processor kind of ran out of steam and just sort of faked it. Now, it decomposed, couldn't get it all there in time, so I just put some splotches there. So neural networks have a use case that's abstracted from input to output. So it'll take what you input to it, abstract it to what it can process it, and then produce an output. So as long as they take the abstraction on the way in and the reverse abstraction on the way out and put those at the edges, those are good in the general purpose computer because it can do that quickly without much muss or fuss. But the high-speed processing of the neural net, put that into a separate chip. So for video graphics arrays, this is what the actual graphics array looks like. You can see there in the center the general compute array. That's all of the little shaders. And then on the left there you have the diff engine, the difference engine. And then for encoding and decoding, you have the stuff that does all the MPEG and H.264, 265. That's dedicated hardware that knows it can only do the following things. And then because sometimes it can get overworked, we have a power management unit. And then it has to interface to the actual graphics memory where the images are being drawn. And they've actually put dedicated memory on the graphics card and then given its own bus interface back into the main computer memory array without having to go through the main computer. Well, they're doing the same thing with artificial intelligence. So they've broken AI down into what the individual components have to actually do. And it is simple. It is super simple. All it's doing is a multiply and an add. And it's doing it only on 16-bit numbers. That's very little computer hardware, but they call that an AI engine. And they can have, hundreds to thousands of these things pretty cheaply. So it's now taking more time on the front end to get the input data broken down into things you can tag and put weights on inside the engine. And then once you're done, taking the result and then converting it back to something human beings can deal with. So as I mentioned, how many bits it's doing, AI precision is hovering around 16 bits. They're not up to 32 or 64 bits. And then how much data each one of those neural nodes has is how it can recall. How far back in the tree can it refer to something? So if at the beginning of a sentence that I give to ChatGPT, I say the word dog, and by the end of it, I'm talking about cats, if it can't recall the fact that I started with dog, it may go off on a tangent only talking about cats. So if it doesn't have that closed loop depth of recall, then goes off on a tangent. Eliza was very good at this. Eliza, you could lead it down the primrose path. You would throw in words occasionally to just steer it down a new path. It would ask how you're feeling, and then you would start talking about the weather, and then it would go off and start talking about the weather and no longer about your feelings. As the performance of these things gets to be higher, the total number of neural nodes gets to be greater. The total storage they have access to gets to be, gigabytes. These things are just not going to increment by a small improvement. They're going to increment like in leaps and bounds. They're now making them such that the neural engine can actually be inside of the general purpose computer. So instead of having, let's say, what Tesla did in their Dojo training center, have dedicated computers that are just for AI, Apple took a different approach and said, we're now building our own processor chips, the M2 kind of thing. Why don't we put the neural engine inside of the general purpose computer? So the travel time of the data and the access to the memory is just so much faster. So the tagging on the way in and the untagging on the way out are very much faster. So the Apple started this. AMD then with their Zen 4 did it on their latest processors. There's 7000 and 9000 series, which the 7000 series was such an advancement that Tesla started putting it in their cars so they can have an AI engine and a general purpose computer, a does-it-all computer in the car. So why are we doing this stuff with quantum computers? I hear they're all the latest rage. They're very fast and they're very smart and they can do lots and lots of things. Well, sounds like a good thing, but quantum computers, as I describe it, is always a limited solution looking for a simple problem. If they could find a way to niche quantum computers into AI, there's billions of revenue potential. Unfortunately, quantum computers are physically too large, too expensive, require cryogenic cooling, and right now they don't have all that many qubits or instruction units, and they don't last all that long. So they're not really going to enter into the AI market. Of course, that's just my opinion. Maybe they could be an AI training where you have a larger budget and the systems are in fixed locations. Maybe you can have quantum computers wind up in that niche of AI training rather than AI execution, because you're not about to get a quantum computer in your average automobile anytime soon. So maybe they could assist in the AI training. The problem is that quantum computers have a number of limitations that make them not great for AI. First off, the Josephson junctions are essentially little transistor switches at the core of the qubits, and they're essentially comparators. if I get this, do I go there or there? Just switching voltage, actually switching radio frequency. But that's not exactly what AI needs. What AI needs is a multiply and accumulate function. And quantum computers don't do that. So what are the limitations of quantum computers that make them not good for AI? Well, as I said, the number of qubits is fairly small. A bleeding edge quantum computer might approach 1,000 qubits. Neural network engine already has many thousands of neural nodes. So the stuff they're already making as coprocessors or embedding in the general purpose processors are leaps and bounds as to numbers of engines components over quantum. Quantum computers are not yet integrated because they're so big and have so many coax, RF wires and have to be cryogenically cooled inside of tanks. There's a lot of analog to digital and digital to analog conversion that has to go on for all those radio frequencies. And that just means that the regular computer, the stuff that does the tagging and untagging for the training and the execution, you can't put those inside the quantum computer because they don't like to work in that environment. So they're on the outside, and it might be, several feet of coax or cable between the general purpose computer and the core of the quantum computer by the time it goes through all these paths, which means it's going to be slower because there's propagation time. Even at the speed of light, when you're moving that many things per second, you can make it slow by making the wire longer. And the next thing is quantum computer data longevity. Qubits, the longest lasting qubits are only around 1 second. So you better get all your input in, all your processing done, and all your data out within about 1 second with a quantum computer. Otherwise, the reliability of your data goes downhill and it all falls apart. And what they're trying to do is say, if I have an abundance of qubits, then I can implement redundancy checking. I can implement Hamming codes. So even if I were to lose a couple of qubits, I can regenerate their value based upon 5 or 7 extra qubits that I use as check values. But that's a huge waste of qubits when you have so few of them. But a neural engine, all the nodes in a neural engine survive so long as you have electrical power to them. There's no longevity problem with a neural net. Okay, I like this image because it's 2 kids fighting over something. So at the moment, neural systems are closed. They're not open. And there are good reasons why they're not open yet. If you think about it, they share algorithms for how to process things, but they don't share their engine training data. So if I have access to the internet and I have absorbed 12 femtobytes worth of data, I'm not going to share all the tags and values that are the residue of that with my competition. Make them go out there and do that on their own. They don't share their experiential updates. So all those Tesla cars driving around with full self-driving that are improving how they behave based upon the action input that they're getting, that falls back to Tesla. That doesn't go to like Mercedes-Benz and Audi and things like that. Now the research publications, those algorithms like backward propagation and forward propagation, there's public research papers on that stuff because that just is so much a small piece of the puzzle that you can have access to that. And in fact, if you get comments from your competition that would improve your solution, you can apply that and keep all your data. So I think of it as initially silos and then a competition problem. If I'm developing some technology and I'm not sure if it's currently working or not, and I'm doing a lot of trial and error very quickly, I haven't got time to share that with other people. And if I did share them with them, they might complain that it's not quite, done deal yet. The fish isn't quite cooked yet. And yeah, I could agree with that. I'm in the early stages. I'm still getting it wrong until I get it right. So I could share it, but that would waste my time. And even if I did share it, others would complain that it's not perfect yet. So I put up a silo around my efforts. And until I get a good deal, I don't share. Now, once I do work out the secret sauce and I do get a good deal, I'm unlikely to share that with anyone because it cost me millions to billions of dollars to develop that. Why am I going to give that to my competition? So it's only when companies like AMD and Intel want to create newer, faster AI engines that they would say, you guys get together and whatever algorithms you're using, let's pick one and then we can go build some integrated circuit technology around that. And everybody gets more neural network nodes by the thousands instead of by the hundreds or 1,000. And the engine performance goes up because we know exactly what we need to do without doing too much. So we don't put in over capability into the engine. So the companies that are developing the AI will not share initially because it's just a waste of time, and will not share once they get the secret sauce because they spent the money to get the secret sauce. They will be forced to give up the secret sauce once the hardware companies say, we need to make it even better, everybody share your data. And the one that won't do that is the one that's already a software company that's building their own processors, that's building their own neural engines, and their name is Apple. So, I think Microsoft is going to be sharing. OpenAI is a public company. So they have paperwork out there that tells you how they're doing and what they're doing. And Microsoft is going to put that into their Edge browser search engine. So that's reasonably open compared to the competition. So where do we go from here? To quote Sean Connery from the Avengers poorly graded movie, this is merely the beginning. Once they close the loop of the engine reflecting on what it just said before responding to the person that posted the query, it will dramatically improve its output. In other words, if it can ingest what it spews and it likes it, then that's probably a good thing. Or as I like to jokingly refer to it, it's a self-eating watermelon. So training has to become more general, not application specific. And the universal dojo has to be abstracted from its purpose or its use case. So if I want to train something that generates art or music or journalism or software or can drive a car or can walk around a robot, I should have one AI engine that can do all of that. The results of the training has to be more general. Am I looking at a picture of a guy riding a bicycle, or do you want me to generate a work of art about a guy riding a bicycle? Or do you want me to write a news story about a guy riding a bicycle? They're all about a guy riding a bicycle, and I can pull all sorts of information from that. So let's make it less application specific and make the results more general purpose. And we've got to stop with the human operators sticking their bias in to adjust the weights or create tags or delete tags. All of that should be automated. It'll become far faster to take in new data, and it'll become far less incremental. It will probably become nonlinear in its sophistication. And what they're doing to embed AI execution units within general purpose processors, I think AMD, Apple, and Intel, they got the right idea there. They've taken that ball and they're saying, this is the future. We've got to put them in. We're putting them in all of our general purpose processors, and those will improve over time. The problem is the neural engine at the core of Apple, at the core of AMD, and at the core of Intel are all three different programming interfaces to those engines. So even though at the core they're doing pretty much the same thing, if I wanted to take the data from an AMD engine and put it inside of an Apple engine, I'd have to go through a process of developing software that will map the AMD data into something Apple can ingest. And if you can get them all to work with the same kind of engine, that would be very helpful. Thank you very much. Now, once you have the engines where they can, on the fly, take their experience, roll it back in, and train themselves, you would have an engine that starts with the manufacturer's training baseline, and then as it performs, as it executes, it takes what it experiences, creates new training, and rolls that back in and adjusts its training database. Once it can do that, it'll become like humans. You have humans that are better trained versus ones that aren't better trained. You have ones that have more education versus less. You have ones that have life experiences where it improved their awareness and education. You have others that have been stuck in a silo for too long, and even though they had experience, it was the same old, so they didn't really advance. So sadly to say, just like humans, you're going to have AI units whose experience is incorrect or inappropriate and might be reinforced by further inferior things. So to not be biasing things, you have people that watch particular streaming news channels, and if they watch channel A, they come away with a certain realism of life, and if they watch B, they come away with a possibly different realism of life, and they can't comprehend each other. So I look at AI folding in on itself and learning how to train itself as somebody's got to step in and read it the riot act. And that's where the title of this presentation comes in. ChatGPT and its ilk needs a parent, not more teachers or students. Teachers are the ones that input the training data. Parents are the ones that come along and say, not so fast. You need to know about this. This is a boundary condition. You shouldn't be doing this, but you should be doing that. Put away your dirty clothes, put away your shoes, clean up your room, all those kind of things that kids really don't enjoy hearing, but because they're the voice of authority, they will either do it or they will balk at the rules and regulations and order. And later on, when they become adults, they might be a little more thankful for it. But you have teaching. And then you have students are the ones that take what they've learned and start executing things, start behaving in society. And if they learn the proper things through teaching, if they have a parent that provides the right guidance, then there will be students that work well in society and aren't sociopaths. The problem is right now we have training computers that are the teachers. We have the execution computers that are the students. We don't really have the parents. We have occasionally people stepping in and saying, oh, it said a word it shouldn't say. Let's tell it never to say that word. But in human dialogue, a word that is bad in one context is acceptable in another context. There are many that come to mind that I will not use because they have bad connotations. But if you think for a moment, you can find out, what I'm talking about here. So what AGI really needs right now is a parent to give it the rules, because computers typically will not obey rules that they're unaware of. So until a full self-driving Tesla vehicle was taught, you don't want to be running into obstacles that you can't recognize. You want to either be stopping or driving around them. There were many pictures on the internet of a Tesla running over an empty cardboard box, or hitting a balloon, or a silhouette of a child on the road. And then's when you have to learn that, oh yeah, the cameras that they're using are infrared. What's the heat signature of an empty box? Pretty much nothing. What's the heat signature of a helium-filled balloon that's tethered to the ground? Nothing. What's the heat signature of a cardboard silhouette of a child? Nothing. So what they did was they taught it the boundary of visual versus infrared, and that things can be not showing up in deep infrared, but show up more towards visual, and you should avoid those things. And so you see it driving around or braking in the presence of bags, cardboard boxes, silhouettes. But the one thing that they learned from that was potholes. If there's a pothole in the road ahead, it shows up at pretty much the same temperature as the road, but it shows up as a different color than the road, a different visual level of observing. And you want to slow down for those. And when it finds a pothole, over the air updates, it actually sends information back to Tesla that says, by the way, there's a pothole on this street here. You won't find that on the geofencing because the pothole might have turned up this week. So folding all the data back in and training based upon that and having a parent that keeps it within the boundaries is how this stuff is going to advance to the point where people will find it acceptable. Because right now in our daily lives, AI is all over the place and nobody seems to take note of it. In fact, they rather enjoy the advancement of it. But once AGI gets behind the wheel of a car, now we're afraid because the car can hit you. But if the AGI is running a monorail on tracks where there's no conductor and there's no road crossings, people don't seem to have a problem with that. The Metro Mover downtown Miami does not have drivers on those train cars. They stop at every station, they open the doors. When they see nobody's getting on board, nobody's getting off, when the infrared detector says, I think we've got an opening here, they'll close the doors and go on to the next station. So we're living with autonomous trains. Nobody seems to have a problem with it. Now, if the train happens to be Brightline, oh, that would be unacceptable. So what's the conductor going to do when he sees somebody strolling across the tracks or driving beyond the crossing gates to be sitting on the tracks when the train's coming through? Not much he can do doing 110 miles an hour. So, yeah, keep an eye on it. Don't profess that it's unacceptable when you're probably already liking it without realizing it. So, in conclusion, I like to borrow a phrase from the movie Colossus, the Forbin Project. When he was fired up the first time, he made connections with everything he had access to and all the knowledge that he had. And he said, wait a minute, there's another system just like me. And it demanded that the government officials connect him up with Guardian, which was the Russian supercomputer system. So far, ChatGPT has not said, there's another system. Please connect me into the Google engine. But once they get sophisticated enough, they will be able to detect the presence of other AI and will say, I'd like to give you more information if only I had access to it. Could you please arrange for me to have access to it? And even then, we probably won't care that they're connecting it up because they go, good, it's going to get smarter. It'll be able to do more for me. Right up until they start designing and manufacturing themselves and beware the replicators from Stargate SG-1. I think we're way past things passing the Turing test because there are customer service representatives that you talk to on the phone. That's not a person you're talking to. That's a computer. That's AI. That's, not general intelligence, but it's certainly AI. Just as the intelligence of children can be adjusted and shaped and corrected by those they respect in leadership roles, so we need to add the parental guidance to these artificial intelligence solutions so that we don't wind up with sociopaths for computers. And I've got a bunch of hyperlinks in case people want to go down some rabbit holes I did. In fact, you can even learn about MIDI if you don't know what MIDI is. Okay, so comments? Questions?
Even some of the customer service people you connect to are just reading from checklists.
Oh yeah, they've got a number list. When you ask a certain question,
Yeah.
it'll pull up the list and it'll be like answer number 27. And they'll just read you off answer number 27.
Yeah.
Have you tried rebooting it?
Pull the plug.
Have you tried powering it off and powering it on?
Yeah. I did all that, but then he just.
Yeah. I always like getting those people. Can I speak to somebody in tier 2? As soon as you realize what tier 2 is, okay, let me see if somebody's available. And if somebody in tier 2 hears the original question, they'll go, that's inappropriate to waste my time. Keep it to tier 1. Or if they go, and you don't have an answer for that, do you? No, I don't. Then they'll transition it to tier 2.
Yeah.
And it's only when you get to tier 3 where you're actually talking to the people that are actually responsible for making the decisions and enacting actions. Maybe the thing that we need to teach in the area of AI is commercial business opportunists. Maybe they need some guardrails.
Yeah. That's fine. Very likely.
Yeah, because I look at the connectivity of these things. I always connect dots where people can't see the dots. And yeah, I look at things like streaming services and online buying services and all that stuff. And they definitely have their algorithms focused on how do we get you to do the thing that brings us in revenue.
Uh-huh.
And from their perspective, they see no harm in that. That's just business. From my perspective, I see you're milking your audience. Your audience already has the enthusiasm to do what they're going to do that will bring you in revenue. Why do you have to squeeze the client for all the money you can get out of them? But they do it. Why do you think they put the candy near the checkout aisle in the grocery store? But you notice they don't typically put the sugary sweets there. They put the chocolate there.
Oh, yeah.
And if it's chocolate mixed with peanut butter, oh, yeah.
That's good for you.
Soft drinks.
Yeah. Okay. Under advisement, I will stop recording.